Good evening, teacher, and everyone who bought this video. Me and my team come here to presentation about stock price analysis. This is our team, and this is our content. So about lump sum method or strategy. What is a lump sum strategy? We investor use that to invest or buy something in one batch of money that they invest for, because most of investor know that the price will rise and they will get big advantage from that.
And another point is the cost average. So the cost average is an investment strategy in which investor have divided up the total amount of their money to be invested in across periodic purchase of the target asset. Yes. Example, we're having $12,000. We're not gonna invest it into one. We have to divide it for each month. We have to divide it for 12 months. So each month we're gonna get $1,000 each. Yes. And that's how the DCA or the cost average works.
Respect teacher again. My name is Visal, and I will show you about the concept of how to calculate the return in our code. Because before to move on the hypothesis testing, we need to know about the mean, standard deviation, and the return. So first is if I'm applying the lump sum strategy. If I have the initial value of the 36 million real, I will invest it all in one. And the number of shares that I bought is 2,222 because of the opening price is 16,200. So I can bought 2,222 shares. And for the year one, I will calculate and find the value of the share at the end of the year that I got is 36 million 44,044 real. So I will calculate to find the return. This is how we calculate. We take the year one, multiply by total investment and minus 1. So this is the result. Is we got 0.0123 return. And for the second year and the third year, it is still the same. And let's move to the cost averaging. The cost averaging is we're gonna take a piece of our amount of money to invest in a period of time. Let's say that we have 1 million real and we're gonna invest it per month for 36 months. This is the opening price of month 1 to month 12. So we will own the total of our share is 644 of the share among the 12 months, and the value of our share is $10 million, 10 million real, and our investment is 12 million real. So the value of our share is less than our investment, so we will lose our money. And we calculate the return for the year one is negative return. So like I'm saying that we will lose our money. And for the second year and third year, we still have the same concept of how to calculate the return. And the annual return of the bot strategy. In this case, we need to find the mean and the standard deviation to take it to use in a hypothesis testing. And this is the result of our mean and standard deviation.
Let's get to our main part of the project, which is about the hypothesis testing. We have 2 questions to test about. The first one is to test between means, and the other one is the deviation. So the first question is, are there significant difference in the average annual return between strategy A and strategy B? So in this hypothesis testing, we will be using two methods. First one is to use the critical region, and the other one is confidence interval. So our null hypothesis testing is that mu1 is equal to mu2, and the null hypothesis is mu1 differ from mu2. So since we don't know standard deviation and the sample size is huge, we will be using the test. And we have the following variable x bar, which is the average annual return of lump sum, and y bar is the average annual return of DCA, and so on, that we calculate from the code demo earlier. So since we use a test, we will be first calculating for the z-score, and substitute all the value in the formula. We would get z is equal to minus 15.26. So the critical, since it is a two-tail test, the critical region is absolute value of z is greater than or equal to z alpha over 2. Calculate z alpha over 2, we get 1.96. So since the absolute value of z is greater than z alpha over 2, so we would say that, so we decide to reject the null hypothesis, and we can say that mu1 and mu2 differ from each other. And method 2, using confidence interval, like I said earlier, so just substitute all the value in it, we would get this number. So since 0 is not in the confidence interval, we say that we reject the null hypothesis. The next one is, we know that mu1 and mu2 are different from each other, but we don't know which one is greater or smaller, so we will be using another hypothesis testing. We have z is that we got earlier, and the critical region for this one-tail test is this, and find that alpha we got 1.64. So since z is in critical region, so we can say that mu2 is greater than mu1.
Greetings, teacher and everyone. Today I'm going to talk about the hypothesis testing for two variances. So the question is, does the distribution of risk vary significantly between the two investment strategies? So today my team uses two methods, and for method 1 is critical region. So we got to test H0 by sigma 1 squared equals to sigma 2 squared versus the alternative hypothesis sigma 1 squared differ from sigma 2 squared. And we have the significant level, standard deviation for strategy 1, standard deviation from strategy 2, and the sample sizes just like the above question. And we got to test the statistic value by f equals to s1 squared over s2 squared, and it has value of 2.58. And for critical region, it's defined as shown. And for f alpha over 2 equals to 1.15, and alpha f1 minus alpha over 2 equals to 0.86. And since f falls within the critical region C, then H0 will be rejected. Thus, we could say that the distribution of risk or standard deviation of returns varies significantly between the two investment strategies. So next part is method 2, that we're going to talk about the confidence interval. And the formula is defined as shown, and it is between 1.49 to 1.72. And since 1 is not in the confidence intervals, so we decided to reject the null hypothesis that sigma 1 squared equals to sigma 2 squares. And we do just like the same as hypothesis testing for two means. We gotta test H0, that sigma 1 squared is equal to sigma 2 squared versus alternative hypothesis sigma 1 squared minus sigma 2 squared is greater than 0. And for this part, we don't know yet if sigma 1 squared or sigma 2 squared is bigger than each other or not. So we have f equals to 2.58, and the critical region for one-tail test is defined as shown, and it has value of 1.13. Since f is in the critical region, so we decided to accept the claim that sigma 1 squared is greater than sigma 2 squared. Thank you for paying attention. Hope you have a great day.